over 2 weeks since I last did a video or an update. What I wanted to do is I've got a few facts I want to show you in this video about what's taking place on this planet, and we'll also talk about the solar cycles. But I think it's also equally important to mention, something that we all take for granted on a daily basis, and it's probably because our daily lives are that demanding, and we're so involved in all what we do on a daily basis that we barely afford ourselves the time to even give them a single thought. Let's take this world we live in. It's very much active. We can extend it to the solar system and indeed the universe. There is nothing at rest at all in this universe. If we bring it back into our solar system and back onto this planet and just look at our individual selves, we look very much solid. But the reality is, what we've found out through studying science is that we're very much fluid. Things that we're made up of, first of all the molecules that make up our cells, and then the atoms that make up the molecules themselves, are very much active and moving constantly. And you may have heard the expression that nothing is at rest in this universe, and it's quite true. If we just, spend a bit of time pondering about, our world and its surroundings, and, one of the very first things we notice, most of us do when we wake up is the sun shining down. Could you imagine trying to light something using the resources that we have that would last for, 10 years? A light, like the sun does. That's doing it every single day and has done it for millions of years. Hasn't lost its temperature noticeably. Keeps its fusion going. Now, it's an arguable fact. Some say that it's not nuclear fusion that's running the sun, it's other things. But if we just put that aside and say, well, it's definitely given light and heat out for that amount of time, then, we can all agree on that. Another way of looking at this constant movement is to describe it in a completely different way, and that would be to describe something changing. Because just like something is constantly moving, it's also constantly, generally changing. And this is what we do as scientists. We observe the changes by recording the data of the changes, and we analyse it in a hope that we can predict the outcome of the changes as they're taking place currently. Some of these changes take place very quickly. For instance, chemical reactions in a laboratory. Some of these changes take place very slowly. For instance, the seafloor spreading along the mid-Atlantic ridge, that we get the data from when we study the magnetite that is set in that molten lava, so that we can record the specific points in our history of where the magnetic reversals have taken place. Because by studying the positions of the magnetite in the rock as it's solidified, we can determine which direction the Earth's magnetic pole was during that change. One of the things I think scientists struggle with today is that when you're observing something for the first time, and you haven't got a lot of data, is predicting an outcome. There's a lot of murky water when you don't have all the facts. And this is particularly the case for the magnetic pole migration right now. Yeah, we understand, only through the last 50 to 60 years, that the Earth has gone through a magnetic reversal many times. But we don't know what happened during those magnetic reversals. We don't know what the climate was doing. what the planet was doing, the internal mechanisms of the planet, the core, what was going on there. We don't know how it was affecting the climate and such on and so forth. And it's very difficult when you're studying, things for the first time. And although, we know a lot about the Earth's magnetic field, the magnetosphere, the magneto itself, how it's generated, or, a lot of it is based on, best facts to date, we still don't know what will be the next chapter in the Earth's magnetic pole reversal. And, I've been studying the magnetic reversal for quite some time, and on 2 channels on YouTube over, 5 or 6 years, we've been talking about it. And in that period of time, I know for some that is a long time, but in that period of time we've seen something very significant happen, and that was the deviation from the vector for the last 100 years that the pole was migrating on, easterly towards Siberia, change. It went from an easterly direction for around 100 years of migrating to a southeasterly direction. And to me, this is an alarming indication that things from this point on may begin to get a little bit more exciting. For some people it won't be exciting, but for certainly me that's observing this, to see a noticeable change like that, it's very exciting. And in the more recent years, say 10, 20 years, we've seen some amazing geological changes. For instance, we have seen small islands push themselves up from the sea surface, and we've also heard of islands disappearing beneath the ocean waves, again small islands. We've seen increases in, volcanic eruptions. We've seen an increase in the magnitude of earthquakes and the frequency of these earthquakes. We've seen weather patterns, turn up in areas that they don't usually turn up in, such as tornadoes, cyclones, etc. These are all, in my view, connected in some way to the magnetic pole reversal. I've been saying, for quite some time now, that if you're in the business of creating planets that are livable and habitable, the first thing on the agenda to consider would be a magnetic pole, because of what that offers with regards to a biodiversity of life forms that can thrive on a planet. It is our protective shield from harmful cosmic rays. It is a navigation tool for migratory animals. It's part of a system that protects a livable planet, and this is the system that is changing on our planet right now. If you go onto the website, there's a good video, I believe that Nova did, that describes, just how important, in a better way than what I do in these videos. I don't script anything. This is just coming straight off the top of my head. But, they've done a very good job of explaining, what happens to planets that lose the magnetic pole, such as Mars. And we know from studying, what we know about Mars, that was possibly a planet not too dissimilar to our own. But for some reason, it lost its magnetic field, and as a result of that, probably lost its atmosphere and water through sputtering, which is a term that describes cosmic rays stripping away the atmosphere, basically, of a planet. And we know they had a magnetic pole and fields at one point because of the probes that we've sent to Mars. We know that this was a very different planet years and years ago in the history of Mars. And here we are today with a similar problem taking place. And why do I say it could be similar? Because if we look at some of the data that we've followed whilst studying the magnetic reversal, especially along those mid-Atlantic ridges, we see that on average the Earth used to go through a magnetic reversal every 350,000 years. This time it's took a little bit longer. It's took 780,000 years. And I asked the question, why has it taken twice the amount of time to go through a reversal? And what will be the outcome of that? Is the process of magnetic reversals slowing down on this planet and stalling? And what are the guarantees that we'll have, a reversal and not just a complete failure of the magnetic poles and the protective shield that we have? Just give you a few moments to think about such things, because that's how important the magnetic poles are. That's how important to me this work is on this channel. And it's not just the magnetic poles, it's what's taking place, like I say, over the last 20 years on this planet with the climate and the weather and the jet streams, because all these things are key to the Earth having a healthy magnetosphere or a healthy magnetic pole. If the magnetic pole fails, then my money's on changes across the range with all those things that we've discussed. Now, before I end the video, I want to show you what's taking place over the Antarctic region right now with the sea surface temperature anomaly. And I just want to show you the vast area around the Arctic Circle at the moment that has sub-zero temperatures. We're talking thousands and thousands of square miles of ocean that is cooling right now. Some of you might think, well, for the time of year, that's pretty normal. Yes, as the Earth goes through its period or cycle of 365 days, it will tilt, putting the lower portion of the planet in less sunlight, and therefore a winter. And 6 months later, it'll begin to tilt the other way, putting the other side of the planet in the same situation. But I'm going to show you something with regards to the massive changes that I've noticed with regards to what is taking place in these regions, more particularly with the jet streams, as well as the notable change in temperature. So let's go and do that. So very quickly, let's just go over a few noticeable facts. The blue region going into the purple region is an indication that temperatures are dropping towards the centre of the Antarctic. You can see in the bottom left corner, minus 54. I've seen temperatures a lot more negative than that in this region, so it's been a lot more colder than this. But just look at the vast region covering thousands and thousands of square miles of sub-zero temperatures. I know we're looking at the South Pole right now from underneath the Earth, if you like, but look at the region that it's covering of this planet on the south, and also note the uniformity of the temperature in that region. Let's compare that with the Arctic Circle now, or the North Pole. Okay, so looking over the North Pole, the Arctic Circle, you can see a massive difference. No purple region at all, and if we look at the bottom left corner, we'll see that it is 0.1 degrees Celsius, nearly 58 degrees warmer than the South Pole, and a lot less region covered with sub-zero temperatures. It's not uncommon for this time of the year for temperatures of even plus degrees of 10 Celsius. So it could be warm, on average in the summertime over the Arctic Circle. You can get temperatures around 10 degrees Celsius. But when we look at the sea surface temperature anomaly, we see a pattern forming, and that is over the northern hemisphere, in general, whether we're looking at the jet streams or the temperatures, we see that it's warmer and less volatile active than what is taking place over the southern hemisphere. Now, I'll just share my views on this. I think that there is something taking place on the inner core of the Earth, more so over the northern latitudes of the Earth. And I think that the temperature is increasing more in the core over that region than it is over the southern region. And, if we look at the migratory patterns of the North Pole, it seems to fit that more activity or more migration is taking place over the northern region of the planet than it is over the southern region. There is a lot more activity across many ranges taking place over the north than there is over the south. Let's have a look at the sea surface temperatures of both the north and the south, and then we'll just have a quick look at the jet streams, and I think that will be it for the video. So let's go and have a look at those details. So these are the sea surface temperatures, just a quick look. Bearing in mind the scale's a little bit odd that this weather modelling system's using. Red you would think would be the warmer, but it's not. Yellow is. Very strange. But let's have a look at the Antarctic region. So we're over the Antarctic region, or the South Pole. You can see the noticeable difference. The Antarctic is covered completely black, indicating it's very cold, and the ocean around it very cold. Big ring of blue around that black, still indicating very cold ocean temperatures. But just look on the planetary scale of things. What you're seeing visually is the southern part of this Earth being much more colder. And yes, even taking into consideration the tilt of the Earth, putting that region of the planet in the winter, it's still remarkably cold regardless. Let's have a look at the jet streams over these regions. And what I'm trying to just point out here is a particular trend, that there seems to be a lot more activity, regardless of whether the position of the Earth's tilting or not, over the northern hemisphere, as opposed to the southern hemisphere. Have a look. So I think we'll end the video here. So, just to summarise, it's been 780,000 years since anything significant took place with the Earth's magnetic field. Right now, in our lives, there are changes occurring with the magnetic poles on this planet. It's a small channel. It's a little beacon of light, trying to put the information out there for people to get. It's international. We've got viewers in places that some people haven't even heard of on this planet now. And some places that surprised me have even got internet access. And although it's only 7,500 subscribers on the channel, we constantly have around 60,000 views a month on, I think it's around about 200 videos now that we've put up on this channel alone. So, we're beaming the light out there. We're letting people know that, when we consider there are 7 billion people on this planet that should know about these changes, because of the impacts that it will have at some point in their lives, and has already, we need to do a little bit more. I don't know why it is. We have, on average, 2 people, support the channel with a contribution every video. I don't know why that is. It's weird, but we do. And it would be nice to get more people involved in that, because with the raising of more money, we could produce, more information. We could get the data that we need. We're trying our hardest on the budget that we've got, and if you've been following me, I always do my best with whatever budget I've got. But if we could expand the budget a little bit more, we could give out a little bit more. the money that we raise on the channel really doesn't even cover the costs of my time. It's not the point. What I'm trying to do there is become a bigger beacon of light for people. Spread the word more, inform more people. These are dramatic changes that we're going through right now. And 780,000 years is a hell of a long time. And just put that into context. Right now, the changes are occurring. It's like we was watching, the magnetic migration over, or studying it for just the last 10 years in particular. We're seeing the changes occur right now. These things are happening. As a result, people have died already in poorer countries as a result of climate change and being misinformed. So what I'm trying to say is it's a worthwhile cause to support this channel. If we can get more supporters, we can do more. We can, spread the information out a little bit further than what we do already. We can improve the data that we collect. The only other thing I've got to say really on the back of this video is, kudos to those people that have supported it for the time that they have, and for those, very special couple of people who support the video, or every video I do on this channel. Thank you very much. I'm glad you share my enthusiasm and join in the cause of what we're trying to actually do on this channel. I don't think there's anything else to say on this video. I'll try not to leave it 2 weeks before I get another conglomerate of information that I feel is worth sharing with you guys. And I think the only other thing to mention is that the link is down there if you want to help contribute towards this research, and the website that we've got, it's there. And you enjoy the rest of your weekend. We live in constant change